Welcome everyone to the last day. This is much easier than screaming. So we're going to have a session this morning on European contributions. And you'll see we actually have quite a nice set of talks. They're quite diverse, covering all the different types of contributions we have. But you've also heard quite a lot of the international in-kind contributions throughout the sessions this week. So our first speaker is Bob Mann, who's going to talk to us about the LSST UK program. Thanks, Bob.
Okay, thank you very much, Aprajita. And this will just be an outline of our contributions, and you've heard and you'll be hearing later on a number of speakers describing individual contributions. And I'm speaking on behalf of the LSST UK consortium, which has in it all of the astronomy groups in the UK, and it has defined the programme of work for a funded project, which is the LUSC, which is working on behalf of and now earning data rights for the individuals in the consortium as a whole. And we were fortunate in that we were able to get organised and funded early, and hence in 2014 we sketched out a programme in phases, which was organised around the LSST schedule as it stood at that stage. And we're almost at the end of our phase B, with phase T starting in April. We're just awaiting the formal announcement of its funding, although actually we've heard what it is. And from here onwards, all the LUSC programme is in kind contributions, and the management that's needed organising that. And overall, our estimate of the budget over the full programme is about £70 million. This is obviously largely staff effort, although there's a substantial amount of computing which we delivered through IRIS, which is a distributed national infrastructure that's being used by all the large astronomy and particle physics projects in the UK. The LUSC programme has three major strands: the DAC, the DRP, and the DEV, and I'll expand on each of these in just a minute. However, I should also note that we're also contributing in a number of other operations roles, in that we're funding Aprajita's excellent efforts as on the IPC team lead. We're putting effort into the community engagement team, and we have a number of contributions underway for commissioning. And overall, our in-kind package is valued at 300 PIs, with most of that offsetting costs for the QS agencies as against adding value. Right, the DAC, the plan is that we will host a full IDAC, and hence we'll have all of the data release products, and we'll also be hosting in the DAC the LASAIR broker, and you'll be hearing about that later in the morning. And obviously, equally in the DAC, we'll be hosting the outputs for a number of our other in-kind contributions. And we have a roadmap for scaling up our DAC. And this is how it stands at the moment. And we've loaded up into it the DP 0.1 data set, and we've just started experimenting with using the community for supporting LASAIR users. And you've heard it earlier in the week, but the DRP workload will be distributed, with the French having half of it and us and the US having a quarter each. And these distributed operations will be using tools that are used in anger in the LHC, and hence we're expecting that our staff in this area, who were just ramping up in numbers still, will be drawn out of particle physics groups in the UK who have expertise in using these at scale already. Then we have a number of dev contributions. You've heard about a number of them, and as you can see, they're helping out a number of recipient groups. Almost all of these have already started work, although I've highlighted the two new ones which will be starting in April. And I shall leave you with my summary. Thank you very much.
Very much, Bob. Is this working? Yeah. Are there any questions for Bob? And thank you for sticking or finishing early, in fact. Any questions in the room or on Slack? Is there anything on Slack or Steam? No. Okay, well,
Yeah,
thanks very much, Bob.
That's good.
Oh, sorry. No, it's okay. Thank you. What is the main need or concern that you have about the contributions of the UK to Rubin, and how can Rubin improve its support to your community and vice versa?
I haven't any substantial ones at the moment. A year ago, if you asked me, I was anxious about the distributed operations in DRP. However, those interactions are now starting up and are constructive. I guess the area that isn't as organized is on the IDACs and understanding how they will interact internationally as a network. But it's early days, and I think that's okay. And there isn't anything that I'm especially anxious about at the moment.
Thanks, Fred. Any other question? So Bob, I just thought it might be useful just to clarify the LASAIR development doesn't come under the
It
UK.
doesn't, although others build on it, and hence
Yeah.
I've mentioned it. But yes, that's right.
Okay.
It isn't earning data rights, exactly.
Yeah. Oh, sorry.
Hi, Bob, just a quick question. Is your investment including the cost of electricity?
That's an interesting question. It includes an estimate of it. Oh, sorry, thank you. It was an estimate as of April. It's obviously more expensive now than it was in April. And there's a lot of discussion actually within our funding agencies about who should be responsible for power costs, which means it's an open issue still. But there is an estimate in there, yes.
Okay, thank you, Bob. Let's thank Bob once again. And our next speaker is Tomislav Jurkic, who's going to tell us about the Bura supercomputer.
Hello, everybody. Good morning. So my name is Tomislav Jurkic. I'm coming from University of Rijeka in Croatia. And today I would like to present our in-kind contribution in the form of Supercomputer Bura that we have on our disposal at the university. We are part of the Croatian participation group, which is an in-kind contribution to the Rubin Observatory that consists also of the Institute Ruđer Bošković with our group leader, Lovro Palaversa, who will give a talk a little bit later about his part of the in-kind contribution. Then we also have University of Zagreb with Hungarian Observatory and myself, University of Rijeka, the Faculty of Physics. And our in-kind contribution is in fact twofold. So the Ruđer Bošković Institute and the Hungarian Observatory have in-kind contribution in software development efforts, and we are giving a software processing center as a computing in-kind contribution. Just a short overview of my research interests. So my main field of work is variable stars and stellar variability. I was working quite intensively on long period variables and Maya-type stars, and also on interacting binaries such as novae, symbiotic binaries, and similar. But also I was working quite a lot on modeling the circumstellar dust and circumstellar environments, mainly in young stars, but also in the long period variables and Maya-type stars, using photometry and fitting of the spectral energy distribution and interferometric visibilities. So our in-kind contribution is mainly active in transient and variable stars. This is our main recipient group, but also in stars Milky Way and local volume, who also endorsed our in-kind contribution. But of course, we are open for any other program or project that wants to use our facility for the LSST related computations. So as a computer resources in-kind contribution, you know that you have two types of contribution. One is IDACs, I will not talk about this. This is more a data access center that are based mainly on large data storage and not so large computing resources. I will focus more on SPC or software processing center, as we are offering our supercomputer as an SPC. So it has a dedicated computer resources, usually for some more intensive analysis and processing. This means a lot of CPU or GPU cores. On the other hand, a drawback is a lower disk storage. So this kind of facility should mainly be used for computing and not for storing any catalogs or any data. So our high performing computing facility, which is called Bura. Bura is a notorious wind here in Adriatic Sea. So it's a fast wind. So we hope that our facility is also a fast one. So our in-kind contribution will have, in fact, a substantial amount of CPU hours, mainly for stellar astrophysics. But as I said, we are not exclusively only for stellar astrophysics. We are open for any other kind of contributions. We plan to offer up to 30 million CPU hours for LSST related work. Then for data access, we have a good cooperation with Slovenian Light IDAC in Maribor. And we also offer astrophysicists domain support to help to deploy any kind of calculations that is planned to be performed on the supercomputer. So what is our aim? Our aim is to analyze first large amount of data, some chunks or bulks of data, but also we are open to small scale computing of individual groups. So if a smaller group wants to compute something on the facility, it can contact me and we can provide the facility to such a group. So I must emphasize that the facility is not suited for development, but only for the deployment of the codes and computer that are already tested, that are already written. So it does not have any Jupyter notebooks and tools for development. A little bit about the supercomputer. When it was installed a few years ago, it was in top 500 the most powerful computers in the world. Here are some of the data. There are around 7,500 cores. It's a Xeon E5 cores in around 300 nodes. There are in fact 3 groups of nodes. I will now briefly describe the architecture. Here you can see the 3 types of nodes. So this is the accelerator nodes. It's a GPU node with the GPUs. Then compute nodes. It's a cluster node with around 7,000 CPUs. And then there is a shared memory node, SMP, with around 500 nodes. But the amount of memory is much larger than if you use the compute node. So here are more detailed information. As I said, the cluster or compute nodes has around 288 nodes with Xeon E5 processors. Altogether, a little bit less than 7,000 cores can be used. But as you can see, the memory is not a big one. So this is more for some for the analysis that requires a lot of cores, a lot of CPU hours. On the other hand, if you have some large catalogs that must be loaded at the same time, and you use a lot of data, then the SMP node is much more usable. But it has only 500 cores, so it's 10 times less than the cluster mode. But on the other hand, you have 12 terabytes of total memory. Then there is also 4 accelerator nodes with the Tesla K40 GPUs that can be also used. For the operating systems, we used Red Hat Linux with the Slarm workload manager. And for the disk storage, there is 1 petabyte of data and another 2.5 petabytes of archive. 10% of this disk storage is dedicated to the LSST. This does not seem too much, but on the other hand, we also have a disk storage extension through the funding from Heising-Simmons Foundation and through regional LSST cooperation grant. And this storage is is currently at the University of Kragujevac, and there you have around 300 terabytes for any storage that you might need in the future. I will also give an overview of some of the science use cases that can look promising, but of course, if you have any other science case that you want to run on the computer, you are more welcome to propose to us. So the first one is the dashboard TVS portal. This is also the part of the of our in-kind creation contribution led by Lovro, Palaversa, and Alexandra Rezim. It should be a data portal for preliminary investigation on LSST-based light curves, so you can see your, I don't know, favorite star or favorite group of stars, how the light curves looks. So the Bura is planned to be used as a backend and more computer-intensive calculations. For example, if you want to calculate some statistics, periodicity, classification, etc. The next one is periodicity mining pipeline that is developed by a Serbian in-kind contribution led by Andjelka Kovacevic and Dragana Ilic and others. It's in fact to the hybrid mode, to the hybrid code that try to calculate and to obtain the periodicity using the wavelet transform and statistics, as well as machine learning for gaps in the observations. And Bura can be used for calculations on large amount of data. And the next talk is in fact about this in-kind contribution. And also, if there is interest to use some other periodicity finding technique, Bura is more than welcome to suit this kind of calculation also. Then yesterday there was also talk by Michele Trabucchi on nonlinear hydrodynamic pulsation models of FPVs. We also developed a nice cooperation with him, and he planned to run his models on Bura. So he planned to calculate a grid of around 3 million simulations of AGB enveloped models to obtain time series, and then also to extract the pulsation periods and light curves in LSST bands. And at the end, this can be used to derive the stellar population models, and this can again be used to simulate the LSST stellar content. Here is one example that Michele showed 2 days ago of the results of such pulsation model. And then the last one is interstellar reddening and stellar parameters that can be also derived. For example, some of this work was already done on the SDSS data, such as simple main sequence fitting done by Barry some 10 years ago. But then also some more advanced statistical approach can be used, such as maximum likelihood estimate or Bayesian approach to derive the reddening and the stellar parameters. So that's more or less what I wanted to present. And of course, if you are interested to use the facility, again, you are more than welcome. Thank you.
Thank you very much, Tomislav. Are there any questions in the room? Or on stop?
Thank you. Hi, I have a more general question related to IDAX as in-kind contribution. Maybe it has been discussed yesterday, but it is not yet clear to me how the IDAX will contribute to the what kind of contribution this will be for users. I mean, will they be accessible for people with data rights? Will they be used to storage as data storage for data taken from the survey, or to run scripts or code or something like that?
Okay. So the Bura is not an IDAC. It should be an SPC. So it will not run the RSP, the Rubin Science Platform, and the access will be provided per user. So from one user to another. Usually the access is through SSH and the VPN channel. So whoever wants to use it for the computing, it will be on personal basis, on individual basis. So it's not that you can access, I don't know, with your RSP login and just go there. You should contact us, and then we can provide the access, and and to arrange everything, and maybe some specific needs that you have, for example, some kind of libraries or programs or whatever you need to run your simulations, your computations. So I'm not sure if I gave you the answer.
So I can give you more details on the IDACs in the break. But essentially all of the above will be possible, but there's still a lot of development work to be done.
Just to be super clear, all the IDACs, all the computing resources are available to everyone with data rights. That's the whole point, is to make these resources available generally to the community, not to provide dedicated resources to only part or some group within the community.
Thanks.
So, of course, it has to be LSST related, and it could be good to be endorsed by your scientific collaboration, so that you do something that has a value for all the academic community, and not only for your group or yourself.
So Tomislav, can I just check? So the way to start projects with you is essentially just to start a conversation by email. Is that your preferred?
Yeah, of course, you can contact me by email. And
Okay, great. Thank you very much, Tomislav. So our next contribution is from Andjelka. I'm going to say your name wrong. Andjelka Kovacevic. Is that right?
Yes.
Okay.
Be blacksmith as well.
And Dragana is also involved in this,
Yes.
but we'll be hearing about the Serbian SAG contribution.
Thank you so much, Aprajita, for a nice introduction. Good morning, colleagues. My name is Andjelka Kovacevic. I am lead of SER-SAG in-kind directable software team on behalf of our SER-SAG team, our project manager, Dragana Ilic, and I will present a report on construction of time domain periodicity mining pipeline for AGN and stellar light curves, which can complement and help other LSST pipelines in frequency domain. And we thank you to organizers of LSST Europe 4 and co-chairs of the session, Aprajita Verma, Federica Bianco, and Antonio, for giving us the opportunity to present this report alongside all these amazing contributions of UK, Italy, and Croatia, because we are coming from underrepresented country. Thank you. Thanks to wave particle duality, signals turn out to be exactly analogs to quantum systems, meaning that the exact time and frequency of the oscillations can never be known simultaneously. And the SER-SAG-1 INCAI team is dedicated to this problem of Heisenberg-Gabor uncertainty principle. And in the next few minutes, we will tour the GitHub repository of our INCAI team, where we are developing pipeline for periodicity mining, which could complement other tools of LSST aimed at the dealing with this uncertainty principle. So why signals in the context of LSST? The LSST cadences combined with the wide extensive coverage will capture a wide range of exciting time domain events populated with interesting background oscillation signals. And what we know we can use the periodogram to convert one-dimensional signal from the time domain to the one-dimensional Fourier frequency domain. We also know that the periodicity as a pre-computed feature of LSST time series will be calculated using multi-band Lomb-Scargill periodogram. And what we know more is that the general rule is that this will work very well when the frequency spectrum is stationary. That is, the frequency present in the signal are not time dependent. And that is challenging, since most of the signals we expect in AGN to see are actually non-stationary in the nature. On the other hand, wavelet transform convert one-dimensional signal into two dimensions, time and frequency or scale. And the heart of our pipeline is our 2D hybrid method, which converts signals from one-dimensional time domain to 2 dimensions, but period plane, using cross-correlation of wavelet matrices. Pipeline is original in that it combines our 2D hybrid method plus deep learning of light curves, and the output will be atlas of estimated periodicities, their errors, quality estimate of detected periods, and the heat maps of correlations of detected signals. Core functionality includes input-output modules, which should follow RSP format, computational utilities, that is the framework for deep learning of light curves, framework for the 2D hybrid method, toolset of statistical decisions on detected periods, and affiliated packages related to the wavelet computation. So we need the deep learning unit for light curves, as some wavelets demand regularly cadenced light curves. And for this purpose, we use conditional neural process, which scheme is seen on the right. And our CNP code is upgraded to the PyTorch and can be run on the GPU. And this code is refactored into different sub-modules dedicated to the uptaking data model, and then outputting the results. The conditional neural process is trained on 2 large ZDCF datasets as precursors, consisting the first one of 40,000 light curves objects and the other 120,000 objects, as well as on really specific 150 light curves of assassin data pre-selected according to the expert criterions. And during these experiments, we also examined the parameters influencing the training process of the neural process, as well our acceleration of the computing process. And we achieved about 10 to some little bit more faster computational speed than using CPUs. And we can see here some models of our conditional neural processes on selected light curves with peculiar characteristics like the strange gaps, strange alternating of the gradients, ridges within them. The heart of our pipeline is actually, as I already said, 2D hybrid method, which takes the input either original or deep learned light curves, and then correlate the wavelet transforms of these light curves. We end up with this map of correlated periodic signals that are presented in both curves, and the axis of the map represent periods. Of course, we could auto-correlate wavelet matrix so that both axes account for periods in single light curve. Moreover, the 2D map can be integrated either along of any of the axes, and in order to create periodogram-like version. And our pipeline is intended to be combined with any other tool dedicated to periodicity detection. What is more important, the different topologies of the map can be used for the classification of the dynamic processes. And currently our pipeline employs WZ method for non-homogeneous cadenced light curves and superlets for deep learned light curves. And we also include the modules for calculating the errors, which is based on Schwarzenberg journey post-mortem analysis, and also the estimate of the significance of detected periods using the Johnson et al. Approach, which is based on the shuffling of the R original series, and the slower method, which is based on moving block bootstrap and fitting generalized extrema probability density function. We also performed the pilot test of massive exploitation of our pipeline on artificial intelligence platform. And on the left, we present the application on LSST AGN data challenge. From the input catalog consisting of 400,000 objects, we selected 983 objects having light curves with more than 100 points, and also constructed algorithm for clustering these light curves, where we found interesting objects having a very low variability over the time. And we compiled the beta catalog of calculated periodicities and their errors for these 983 objects. On the right, we can see, on the far right, we can see actually results for exploitation of our pipeline on 1,000 artificial light curves for preselected OPSIM cadences with the injected periods, and the heat maps represent actually relative errors of detected periods for different level of amplitude of the signal and LSST cadences. The most demanding task in our pipeline is actually estimate of statistical significance of detected period. And for example, using 100 mock light curves will need more than 1.5 hours at personal computing station. However, at AI platform, we can do it for several minutes. And we have also, as a team, some different auxiliary projects, and we are thankfully to the support of LSST enabling science. Our two PhD students, Isidora Yankov and Iva Čvorović Hajdinjak, contributed to conditional neural process module, which is the part of the pipeline. And also we produced photoreverberation mapping module. We also published during this conference upgraded Pythonic PyZDCF mirroring code of famous Fortran ZDCF code of Tal Alexander for cross correlation, and you can see it on the Slack. And we also contribute to the LSST, cooperate with the LSST community through estimate of OPSIM evaluation through different published white and scientific papers. Also, we contributed to the link white paper with 2 codes. And also we are now preparing with our other data challenging AGN teams publication for the APJ. And we are really thrilled and grateful that we could cooperate with the Croatia participation group within the LSST through the Kickstarter project approved by LSST TVS scientific collaboration. The leads is from the Croatia side is Tomislav Jurkic and Lovro Palaversa, and we are also grateful that we could investigate together with Marta Fatovic, PhD student from Croatia, and Lovro Palaversa and other colleagues on interesting case of binary quasar candidate, which is an excellent example how our method can complement Fourier methods. And as for our future work, it is really important for us to design statistical decision on the quality of detected periods. And it is really important for us to go out and to cooperate with Tomislav on Bura and exploit our pipeline on Bura. And the most important, to cooperate with Lovro from CPG team in order to implement our light version of the pipeline into Dash. And we are so much grateful to you for your attention. And here is the ID of our SER-SAG team. Thank you so much.
Thank you very much, Andjelka.
You're welcome.
Are there any questions?
Andjelka, this is so impressive. And did I just hear you saying that you published a paper during this conference while you were
Not paper, the code.
You published the code during the conference while you were also
But that is the
playing a major role in running the conference. I just want to frame that for everybody to hear it loud.
And we get the feedback from the AGN community already. Yes.
That's outstanding. I have a question for you, which I'm a little bit worried about asking. How is the fact that your recipient is a science collaboration, but you're doing a contribution to Rubin, so you owe your reports and you owe your work to Rubin. How's that working? how can Rubin and the science collaborations improve that interaction?
Oh, okay. So thank you so much, Fed. You are so kind person. We are all the time thinking how we, from our side, could improve communication. Up to now, we do not have any how to say, complaint. We are so grateful to Aprajita and other IPC officers, which helped us a lot. Our question was almost immediately answered with super useful hints and points. And maybe if Dragana, as a project manager, would like to say something on this theme. That is from my side. I do not have any.
I know I'm not wasting time. I'm taking time. I just want to say that that point is very important, that we should all together work on communicating better with the recipients group. And there has been some discussion. We did the informatics and statistics session that we should organize different joint seminars, so people kind of talk and represent what is happening across collaboration. So I think maybe this more cross science collaboration communication is kind of important. And we are maybe giving an example because we are both AGN and TVS, and we are trying to bring together communities, and I think that's important. So
thank you, Dragana.
Yeah, that's fantastic feedback. Do we have a slide?
Yes, so there's one question online. Monica Jurkic asked, how many variability types are you separating? How many variability types are you separating?
So actually, that is an interesting question. We have been calculating the heat maps for the AGNs, for example, where we can discern between the different dynamics. For example, between the perfect oscillators, the oscillators with the attractors. Then we also discerned between AGNs which can have, however, which can belong according to the standard classification to one group, but dynamics of detected periodicities according to heat maps are different. So our pipeline can be applied on the level from the minutes up to the years of oscillations. And we also tested on VLF signals. That is the signals which are emitted from the ground based emitters on our planet, and they are passing through the ionosphere of our planet, and perturbations of these signals can be of the order of the minutes, but time series is very densely sampled, about 30, for example, 36,000 points per 1 hour, and these signals can be associated with the earthquakes. And we tested our pipeline on the time series, VLF time series, collected 2 hours, 1 hour during the earthquake in Serbia in 2010, and compared this topology of these heat maps with the day 1 year earlier. And we can see in these heat maps that we detected some specific dynamics which can be associated only on the several hours before the occurrence of the earthquake. So actually our pipeline can be used either for the AGNs stellar on the level from the minutes up to the years of the periodicity. So that is from our side.
Well, thank you very much, Andjelka. So our next speaker is Lovro Palaversa, who's going to tell us about the TVS dashboard. Thank you.
Hello, everyone. I have the difficult task of impressing you after all these fantastic talks. So I hope I hope that your expectations are not too high. So I'm here to present. Can you actually click on the online version, please? Because I updated it. You just click here.
Why don't you start and we'll do.
Okay. Yes, that's fine. My name is Lovro Palaversa. I'm the program manager of the Croatian in-kind contribution that Tomislav already introduced to you. So if we could go to the first slide, which I will actually skip. Okay, never mind. It's probably not that important.
I will try to retrieve it in the background.
Never mind. So there are three parts to the Croatian in-kind contribution. Our part of the in-kind contribution is based at the Ruđer Bošković Institute in Zagreb. It's a directable software development, and what we are developing is the TVS dashboard. It is an online web-based tool for first look analysis of your light curves. A few words about the Ruđer Bošković Institute. It's the largest Croatian research institute, hosting around 750 researchers across all fields of natural sciences. There are approximately 20 to 30 people interested in astronomy and astrophysics there, divided into three groups. I'm part of the optical group, and I'm also the PI of a project that has 4 postdocs, actually 3 postdocs and soon a 4th one, and a couple of PhD students, and we are also working with undergrads all the time. Our interests are mainly in variable stars and transients, survey and data science, distance scales and distance determination, and the structure and history of the Milky Way. And we are active in the LSST and Gaia for several years now. So TVS dashboard, its main purpose is to provide a graphical interface for preliminary analysis of the light curves obtained from the data releases that will be published by the Rubin LSST. So this means that we are probably not going to ingest data that is going to be published by brokers in the real time. We also aim to provide convenient access to the science products developed by other science collaborations and teams in the science collaborations, brokers and third parties. And we also want to simplify access to users without previous experience with Rubin LSST, astronomy in general, or time series analysis. So we will make a brief pause here. Okay.
The right spot?
One back, please.
One back. Okay.
Yes.
I will control the slides for you, but now you're on the live version.
Okay, perfect. Thank you. So I think the corrections that I made were on the previous slide. Never mind. So the planned functionality that we aim to provide for the TVS dashboard is basically selection tools, selection of your data through ADQL queries, filtering, freehand selection, and possibly unsupervised machine learned clustering that will be pre-computed for the data, so it won't be executable by the user because of the hardware requirements. We also aim to provide simple plotting facilities like scatter plot, density plots, histograms, and so on, and tools for the analysis of light curves. So this will be some simple statistics, periodograms, and plotting of the folded light curves. Again, depending on the hardware availability, it depends how many sources will a particular user be able to process on demand. So most of these data will be actually pre-computed, and we will ingest them from other providers and just give a framework through which you or the potential user will be able to access these data. We also aim to provide access to other facilities where you can actually launch more complex and more hardware demanding jobs. So these would be basically run on SPCs and IDEX. And we also aim to integrate our dashboard with the TVS observation program management tool, which is being developed by a team in Heidelberg, led by Yanis Tsapras and Markus Hundertmark. So we've been collaborating with them since the beginning of this project. And ultimately, we will also provide the API. So you can actually, if you find useful some of the functions that we provide, you may actually skip the graphical interface if that is too slow for you. So where do we see ourselves in the Rubin LSST ecosystem of software and applications that are going to be provided? So there are general resources that are going to be provided by the RSP. There are also VO-based portals that will provide access to data and data products and broker alerts. But there is also a niche here that's mostly related to the portals that are interesting to the IDEX and science collaborations. So we actually aim to cover that area and provide easier access for the products that are being developed there. The current status. So in spring this year, we filed the joint DASH and OPM questionnaire. The response was quite good. We received quite a lot of input, and based on that input, we organized interviews later on with the interested parties that wanted actually to share their vision of, well, actually to share what they would like to see in the TVS dashboard. This was, of course, very useful, and having this information, we were able to draft the first version of the DASH software requirement specification document that is available online. You can see it and comment it. We intend to keep updating it as our plans and goals change. And currently we are working on the design specification document, portal layouts, and backend libraries adaptations. So backend libraries are actually the software that is going to do all the work of ingesting various slide curves and various data products that we will be publishing on the dashboard. There are quite a few aspects that still need some clarification for us to proceed with the work. So first of all, we need to understand how the RSP's authentication mechanism is going to work. We need to figure out exactly where the dashboard is going to be hosted. So is this going to be somewhere on the hardware that is being used by the RSP, or perhaps IDEX are going to provide the hosting and computing resources, because we in principle are not offering hardware for this. We're just developing software. And we also need to actually find out exactly which other data products are going to be provided by the brokers and in-kind teams, and make some decision on what are we actually going to offer in terms of the ancillary data to the Rubin data that will be available. Next slide, please. We also have a wish list, so we are open to collaboration, and we would like to hear your ideas and hear about what you would like to see in the TVS dashboard. So please get in touch with us, and also get in touch with us if you are developing something similar, or you're looking to collaborate us on any of the aspects that might be related to TVS dashboard. And in particular, we would be very happy if someone would come up with a library of and a well-maintained library of nearly all period search algorithms that are currently known to humanity. This would be very useful. So I think this is probably a good idea for someone who is thinking about, oh, what could I do as a software in-kind contribution? This would be a very nice project. We would certainly do it if we had more people that could work on it. And we are always looking for people that are willing to do the period searching for millions of objects, and do model fitting and classification of variable objects, which would certainly be very helpful for us, either in the terms of just ingesting the data that they will pre-process, or actually offloading some of the data that users would want to process on their own. I think this was the last slide, and thank you very much.
Thank you very much, Lovro. I think for TVS or the others, I think you should consider a general pool request for the period library.
Yes, that's actually a very good idea.
Yeah.
I haven't thought about that.
Are there any questions?
George Beggett asked, is there an option to develop the dashboard within one of the existing interfaces, e.g. Firefly web interface or tailored Nublado notebook interface, so it can be easily accessed alongside other functionalities?
Yes, we aim to actually develop the dashboard in such a way that it's very modular. So ideally, it would be like easily pluggable into any other framework, even something that's not related to LSST. So if some other survey likes it for some reason, they could just port it to their own version of the dashboard.
Thank you. Any other questions?
There was a question in the back.
It was very similar to George's question, which is if I've started working in Edinburgh or the US somewhere, and I discover I'm interested in TVS, do I have to re-authenticate to a new place, or is there something that will be transferable across all the different parts of the Rubin project? But it's so close to George's question that I think you need to answer it, but not now. You see what I mean?
Well, this depends actually on how the authentication mechanism is going to work. So we can't answer it yet, but we are aware of the fact that we need to figure it out.
Okay, great. Thank you so much, Lovro.
Thank you.
So our next speaker is Ken Smith, who's going to tell us about LASAIR.
Yes, thank you very much. My name is Ken Smith. I've been working with Pan-STARRS and Atlas Transient Science Servers for, well, basically since 2009. So we've got involved in LASAIR, the UK transient broker, because of this past experience, and because in the likes of Pan-STARRS and Atlas, we're ingesting, admittedly, a lot of junk, but a lot of detections, difference detections coming from those platforms of the order of 50 million per day. So LASAIR, by the way, just means flash or flame. It reflects, it's a Gaelic word. It reflects the cooperation of the Edinburgh and Belfast software developers. And this is the team of developers across those two institutions. And Stephen is also now in Oxford. So this is one of the 7 brokers that receive the full stream of alerts from LSST. And the screenshots that follow, I should tell you, well, I'll come back to the screenshots. I'll just mention that we are in the process of updating the web interface. Okay, so I was given this slide deck kind of template, and there's a little link of glossary of acronyms down below, which identifies what an actual broker is. So we're basically mediating the data coming from LSST, allowing users to tune what they receive from this large data stream of transient alerts. So Leanne gave a good introduction yesterday. So LASAIR itself, we've been active since May 2017, working on the parallel, or I said kind of trailblazer ZTF platform. So that uses the same mechanism to transfer alerts to us. It's a thing called Kafka. Again, don't worry about the technology. For the most part, you don't need to know about it. It's a messaging system. So in our database, at the moment, there are 275 million or so alerts. Now, if that sounds a lot, of course, that's only a month's worth of LSST, even though we've been operating since 2017. So we're very much moving into a different order of scale when it comes to dealing with the data coming from LSST. So I could go on. About 16 million of those are identified as static transients, i.e. have a light curve of more than one detection. So a whole bunch of those are singletons. So we have 298 or so users from all over the world. We are world accessible. So examples of those are the supernova and gravitational lensing follow-up groups. Foremost and TIDES are using LASAIR to triage where they put the fibers. INAF looking for TDEs and fast blue optical transients. See our research note up here. Again, research notes were mentioned by Leanne yesterday. So the core of LASAIR is an SQL query interface. Probably not very clear from this slide. But we give you example queries. We give you examples of other people that are already using the system. So live queries that are currently in use. The queries are actually done on the core database, but we also have streaming queries that work on the contents of the packets coming through from LSST. In this case, of course, ZTF. So the output of those of the SQL that the user has created in order to tune what they want to receive from LASAIR can be placed on again, one of these messaging queues, Kafka, or emailed, or other ways of alerting. We have a cone searching box as well, which is becoming more flexible as the web interface develops. So you can search by the host galaxy, for example, and you can get the results in JSON or CSV, etc. So we allow users to create watch lists and watch maps. Watch lists are the lists of your favorite objects, up to 1 million or so of your favorite objects, RAN, DEC, and name, and search radius as well. And we will trigger an alert if we receive a detection that is close to one of your objects. Likewise, the watch maps but they're basically HELPIX maps. You can define HELPIX maps on the sky of areas that you're interested in. This has, of course, relevance to gravitational wave follow-up. And we can trigger objects that lie in the vicinity of those maps. So this is another part of the core of LASAIR, which is the context classification. Again, it's as good as our locally curated catalogs. So we have the likes of Pan-STARRS DR1, for example, Gaia. We're looking at ingesting one of the ZTF DR3 and other surveys. Of course, in the south, the catalogs are much less homogeneous. And hopefully LSST DR1 will help us to identify, using whatever algorithms are implemented in Sherlock, which is my colleague Dave Young, to identify what is the probable host of the transient that we've discovered. The alerts, as you may or may not know, contain a limited time time coverage of the previous N days. So for ZTF, that's the previous 30 days. For LSST, that will be 12 months. But of course, the database that we have will curate all of the light curves. So you can do queries directly on the database that won't be in the alert packets themselves. So you can create ad hoc queries, etc. We're working with other brokers and other users to identify strengths that they may have in terms of identifying what a characteristic of a transient, feeding that back into our broker, and then allowing users to do queries on the results of other brokers and effectively get alerted if an object, for example, has been flagged as interesting by, for example, Queen's Fast Finder or the Fink broker. So we can combine results from other brokers, and we're working to create an interface that other brokers can use to feed information back to us. Again, as I mentioned, HELPIX maps earlier, we also in 03, of course, dealt with the same kind of helix maps for multi-messenger follow-up. We do this in Atlas and Pan-STARRS as well. It was difficult to test in time of ZTF because of the way the ZTF program worked on follow-up of objects that happen to be in the 90% probability area. But we'll be looking to provide a multi-messenger follow-up service in 04 as well. So this is our REST API. Users can programmatically interact with LASAIR using the REST API. You can follow those links. All those links should be live to get information on how to interact with that API. And we have Colab, Google Colab notebooks, Jupyter notebooks that will identify examples of how you actually use this. We actually use it in Atlas at the moment to dynamically cross-match against ZTF when we're discovering new objects. That's our scalable architecture. As I mentioned yesterday, it's Iris, our UK cloud infrastructure. What we've just completed, I should say this is our third iteration of the platform. We initially deployed on bare metal, when we then deployed into the first iteration of the cloud infrastructure we call Somerville. It's our codename Somerville in Edinburgh. And then we've migrated again to a new cloud infrastructure, which includes SSDs, which does reduce the latency in response time. The different parts of the infrastructure are scalable. So as we increase the number of alerts that we need to process on a daily basis, we can increase the number of nodes in each node. And we're actually using Kafka again, the messaging system, as a bus to transfer the alerts through the system. So coming soon, we're doing a web update. And again, Dave Young has come in to help us with that. We already have some cookbooks when you go to LASAIR to help you kind of dip your feet into the workings of LASAIR. We have documentation, but we're also working on new documentation and potentially organizing a hackathon. We met together as a group of, we gathered a group of transient scientists together to discuss ways that we could augment the DIA object features with features that we've decided to call potentially explosive transient features, working on the early part of the light curve as the light curve comes in, it's built up. So then, of course, the immediate next stage, we're actually working on this at the moment, is to translate from ZTF to the LSST schema. And then we want to also prepare for interaction with force photometry. We know that we're going to get force photometry in the alerts on the second day, but what we would really like to do is to go back on the first day and actually grab the force photometry. So in case it's a fast transit, of course. And then we're going to want to prepare for the start of the LIGO Virgo CAGRA in 04, which is coming up in March. Hopefully, some part of LSST, whether it's ComCam or LSST Cam, will come online. And then we'll get ready for 05 in a couple of years when the designers are working on the design sensitivity. And eventually we want to work with the solar system collaboration, funding dependent, of course, on alerting on solar system objects. So just before my last slide, I mentioned other brokers, the two other European brokers. This is a European meeting. So the two other European brokers are Fink and Ample. And the links are below if you want to know more about the other broker information. So we meet regularly to discuss things like the way our locally curated catalogs work when it comes to cross-matching objects and identifying the potential host galaxy of an object. We've been talking about possibility of having a common stamp archive. What do we do with these inputs, reference and difference images that they come in? So light curve classification, load testing, multi-messenger alerts, how do we deal as a common, maybe as a common European platform with multi-messenger alerts, and possible exploration of joint funding opportunities. So finally, that's it. Questions, and again, Leanne pushed the community forum, and we have under support and LASAIR any questions you have about LASAIR and interaction with it. Thank you very much.
Thank you, Ken. So we're running a little bit behind, but we can take one quick question. There is in the room. Steve, is there anything online? Sorry, Austin. Okay. You had one.
Hi, thank you. This is great. You all had such a long experience with brokers, so it's great to hear this. The interaction with the multi-wavelength community and response and coordination with space telescopes. Can you tell us anything about that?
So we've already had experience of that with Atlas and Pan-STARRS in consuming the alerts coming out from the LIGO Virgo system, and identifying transients that potentially might be interesting. So if we find something that's, for example, fast fading, those are the kind of things that we want to immediately trigger follow-up on other alerts, other systems. So previous system that we worked with was ePesto Plus, that follows up transients in down at NGT. So we have an automatic feed from these older systems into the Marshall that triages follow-up of these.
Thank you. Great, thank you, Ken. Let's thank Ken again. Our next speaker is Johan Knapen, who's going to tell us about the GTC contribution to the in-kind program.
Good morning. My name is Johan Knapen from the IEC in Tenerife, and I'm going to give you a little talk about our very modest contribution to the project, which is time on the 10-meter GTC. But before I go there, just introduce who we are as Institute, the IEC. We're in the Canary Islands, which is part of Spain, but located a few hours flying south of the mainland. The first tests for astronomical sky quality were done by Smith in 1856. We've got meteorological records at the observatory going back for 90 years, and we've been doing professional astronomy observing there for about 50 years. Excellent sky quality at the observatories, thanks to atmospheric inversion, a cool ocean, and stable trade winds, very similar to the Hawaii Observatory in that respect, islands in the middle of the ocean. The sites are protected by strictly enforced sky laws, and they cover light pollution, radio pollution, atmospheric pollution, and air traffic control. And the median seeing is about 0.7 arc seconds. And the quality of the sky led to the founding of our institute, the Institute of Astrophysics in the Canary Islands. And it's interesting to note that before that, there really was no notable astronomy research in Spain at all. So everything I'm going to show now has come up from zero over the past decades. So the IEC is a large institute with close to 500 staff, about 70 permanent astronomers included in them. 3 main divisions: research, graduate studies, and instrumentation. We do technology development. We're involved in many instrumentation projects, and we have a very wide research program covering from solar system physics, solar physics to cosmology. Our headquarters are in Tenerife in La Laguna. We have a sea level base on the other island of La Palma, and then we own and manage 2 observatory sites, one on Tenerife and one on La Palma, both located around 2.5 kilometers altitude above sea level. So here's an overview of where the 2 are. The photo in the foreground, you see the observatory in La Palma with some of the telescopes. The volcano was near here last year. And in the background, you see the highest mountain of Spain, Mount Teide, and next to that is the location of the observatory in Tenerife. And as you see in this picture, the cloud level is usually below the observatory, which helps obviously. So this is an overview of the Teide Observatory on Tenerife. Solar telescopes are based there, which are the towers, and many small facilities, many robotic small telescopes. I think we've got about 40 telescopes in total. And since we're in Italy, I should mention Astri, which is the mini array of 9 Cherenkov telescopes of about 4-meter diameter each, which is being constructed at the moment. The first telescope is there, and the others will be there soon. So that's also at Tenerife. And this is a picture of the observatory in La Palma. So coming to the 10-meter GTC, the Gran Telescopio Canarias, this is a 10.4-meter equivalent segmented primary mirror, 36 hexagonal segments of the mirror, fully operational now for over 10 years. We mainly operated in queue mode, but we also have visitors, so you can come out to do your visitor mode observations, including remotely. Target of opportunity observing is supported, which is interesting for this project, of course. And there's a full instrument suite and funded future instrument development plans. There's 2 very large Naismith focal platforms at the telescope, a Cassegrain focus and multiple folded Cass focal stations. So here's an overview of the telescope on the left, and you see this one of the big Naismith platforms to the left of the telescope structure. Here's some more overview pictures, so you see where the telescope is located at the observatory. And here are some photographs of the telescope. On the top left, you see these 4 dark holes around the side of the telescope. Those are the folded Cassegrain focal stations. And the top right is the Hypercam instrument built by Vic Dillon and his team from the UK. This is a 5 optical band simultaneous high-speed imager, and it's mounted at one of these focal Cassegrain stations. And on the lower left, you see one of the mirror segments taken out of the telescope and into the mirror lab, where it's been re-illuminized, and you see all the support structure at the back there in the photo. So the instrumentation covers a large parameter space. I'm not going to go through the details. This will be in the slides, and there's a link at the bottom here that also shows you the future instrumentation plans. So this covers optical and near-infrared imaging, spectroscopy, including multiple object spectroscopy and integral field spectroscopy, and Hypercam is there, which is the multi-band high-speed imager. So our in-kind program, what we offer is around 1% of the time, which is several nights per year of GTC time to the LSST community during the entire 13-year duration of the project, which is to be allocated through competitive peer review. This includes everything. It includes all the moon phases, all the RA range, and the complete instrument suites. No preference, but also no restrictions on any of those. It can be used to follow up discoveries made with the LSST, including target of opportunity observations and both queue and visitor mode observations. So observers wish to come out and visit us, they can. I've talked about the instruments already, and our strategic aim here is partnership and collaboration between the ISC and the wider LSST community. What's our interest in LSST? Well, first, there's a wide-ranging scientific interest that we have in the project. We're aiming for 9 PIs from our institute, and the names are here. And the science interest that they have, this ranges from solar system physics to cosmology. And if you wish to collaborate with people and explore this, then these will be the names of your main contacts. Several colleagues are present, and many others are active in the science working groups of LSST. And as I said, our strategic interest is increased collaboration with the US community and involvement in this world-leading project. There are other ways to access GTC time, which I should mention here. You don't need to wait for these, the formal LSST time to come on. One is to collaborate with the people who already have access to the GTC. That's mostly Spain, but we have small participations from Mexico and the University of Florida. Proposal PIs must be from one of these communities, but if you have a good idea and wish to collaborate, you should find a collaborator from one of these 3 communities, and they can then act as PI of your collaborative proposal, and you could access telescope time that way. If you want to be PI yourself, then you can use the International Time Program, which is an annual call for proposals on many Canary Island telescopes. The deadline is always at the end of February. This is administered by the International Scientific Committee. Proposals must contain COIs from at least 3 of the CCI signatory countries, which are Spain, Italy, France, Germany, Belgium, Finland, and the UK. So it shouldn't be too hard to find 3 COIs from those countries. Ideally, that's the aim of the project, is inter-telescope use, so use more than 1 telescope for your science, but 1 telescope proposals are accepted. So you could write a proposal for the GTC in this program. And there's 5% of the time available on any of these telescopes that are listed, and a few more. So that includes the GTC, it includes the William Herschel telescope with the new WEAVE instrument that's being commissioned. It includes the Italian 3.5 meter TNG, the Nordic NOT, the UK, Dutch, Spanish Isaac Newton telescope, the Liverpool telescope, Mercator, and a handful more. So as I said, the IEC warmly welcomes proposals for collaboration across the LSST collaboration. So here's my summary. Our in-kind offer is observing time on the 10 meter GTC telescope, time offered for US, Chilean LSST proposals, offered across all instruments, moon phases, RA range, etc. As I said, no restrictions and no preferences. There are other routes to obtain time, which are in collaboration with GTC partners or by applying for international time. And we welcome ideas for joint proposals or collaborations. Thank you very much.
Thank you very much, Johan. Are there any questions? Nothing on that? So can you tell us a little bit more about how you propose to allocate time to the international contributors through the in-kind?
That's not been fully negotiated, so I won't go into details here, but we have a procedure that we're discussing with the LSST project team, and it will be competitive peer review, and we wish to be as open as we can be in terms of the best science has to come out. That's the interest for both parties.
And do you know when you would start offering that? Is that also?
That depends on when we sign the in-kind agreement, but we want to start as soon as possible, ideally ahead of the LSST observations, just to get collaborations going. We're ready to go ASAP.
Thank you.
Thank you, Johan. Just a related question to what Aprajita just asked. So basically, if I understood well, the in-kind contributions through the telescope time should be coordinated within the ION network. So are you, in your case, this is kind of special?
Yes, we're not within that network.
Ah, okay.
Yeah.
Yes.
Yeah, not all contributions have to go through AON, although it's preferred. So I think this is one that doesn't. Yeah, it's preferred, but not. Yeah.
As I said, there's also no preferred angles to this. So you could do target of opportunity follow-up observations, but any other science would also be welcome, and then subject to peer review, obviously.
If there are no other questions, let's thank Johan once again. So we now have 2 short talks. So apologies already that we might eat into your coffee break a little bit. So we have the first one from Róbert Szabo from the Hungarian Plenary Observatory, who hopefully will be sharing his slides online.
Yes, hello. Can you hear me?
Yeah, we can hear you. If you could share your screen.
Yeah, I started. Oh. Okay, can you see it now, right?
Yeah, it's not full screen, if you can.
Yes, like that.
Okay, thank you.
Okay, thank you very much. Thank you for the opportunity. I'm Róbert Szabo from the Plenary Observatory, and I'm the leader of the Hungarian in-kind contribution. I'm going to be trying to be as fast as possible. Say a few words about in general, about the Hungarian Concoli contribution. This is an ambitious endeavor. We are aiming to have 5 PIs. Previously, before the in-kind contribution era, we had 2 PIs. Now we are aiming to expand this contribution to allow more research groups to join. We are interested in the TVS and stars, Milky Way, local volume, as well as in galaxies. There's a strong interest in solar system studies and also in transients within the TVS. This contribution has 2 parts. The first part is a general pooled software development effort led by Zsolt Frey at the ELTE University in Budapest and by Gyula Szabo from the Gotthard Observatory. This is a smaller observatory in the western part of Hungary. These are still in the phase of negotiations, so I won't touch these so much. And I'm gonna focus on the second part of our contribution, which is a directable effort in the TVS science collaboration to develop a general machine learning algorithm to classify periodic variable stars. I'm working on this with Attila Bódi and Tamás Klenár, 2 colleagues from the Concoli Observatory. They are present in Rome in person, and I apologize that I could make it only through Zoom. So this is this part of this contribution has already started, and the main aim is to provide a framework for periodic variable stars for TVS users to have to have an idea about the classification of a given object or about their favorite objects. So we in recent years we have been working on a very specific algorithm and a very specific approach to this problem. This is a very huge problem, how to classify variable stars, and this is just one example from the TESS collaboration, from the TESS space telescope, where the general approach is to have several different kind of algorithms to classify all kinds of variable stars. But in general, what has been the general approach is to use the light curves and to use some parameters, some mathematical descriptions of the light curves as mathematical functions. So you compute the range, the maxima, the scatter, whatnot. You can compute infinite number of various parameters, and then the task is usually to find the best set of parameters that will allow you to put objects into different classes. We, however, have a different approach, and what we try to do is to mimic the human brain, to human vision, and use these light curves, usually face-folded light curves in case of periodic variable stars, as images. So if Google can classify and tell apart cats and dogs, then we should be able to do that. So what we are doing is something like that. We feed face-folded ogle light curve from the ogle survey, and this CNN convolutional neural network works pretty well. Turns out well over 90% in most of the cases. We published 2 papers. One is simply using these images, and the other one we complemented this approach with several numerical parameters like periods, colors, parallaxes, distances, whatnot, and it turns out, of course, that it improves our algorithms. So the general idea in this contribution is to have a very general framework, and this image-based approach can be one of the algorithms that we can include. So the idea is that we have the light curves. We have external parameters like periods from brokers or from the Serbian contribution or from other sources, and we put all these together and provide some probabilities for various variable star classes that can be very general, large classes, or we can even go into details and provide subclasses like RRAB or RRC stars in case of RR variables. We intend to run this whole algorithm on the Rubin Science platform, and we also think about providing user interface where you can just give your favorite objects, and this machinery gives you back the probabilities. And with more and more data, we will be able to improve this classification. And so we are planning to provide periodic updates when new data are available from LSST. And of course, we'll provide documentation and help, technical help. And as I mentioned, this is already ongoing. So what we did without actual LSST data, we used ZTF as proxy, the ZTF data, and selected variable stars in G and R. So we have multiple passbands, which is important because LSST will have 6. In most of the cases, you have only 1 or maybe 2. So we have preliminary results and use this ZTF data, and this kind of algorithm runs pretty well and provides very high percentages completeness and precision, well over 90%. So that's what we are working on right now. And I will stop here. Thank you very much.
Thank you. So we have time for one quick question for Robert, otherwise we can carry on chatting on Slack. Okay, just in the interest of,
Hi, just a very quick but technical question. So classifying cats and dogs are very obviously distinct objects. Not always in astrophysics, the classes that we have are really truly distinct phenomenological phenomena. Does that worry you?
It depends in what detail we intend to go into. And I think what my experience is that the human brain is pretty good. And so based only on the light curve shape, it already tells you a lot. And if you provide additional information, like I said, period, luminosity, whatever you have, that's pretty much what you have. And the algorithm will learn all those tiny details that will tell these light curves apart. That's at least in an ideal world, that's how it works. But we already they demonstrated that it works pretty well. So I'm not worrying that much about that.
Thank you very much. Let's thank Robert again. And our final talk, again, apologies for running into the coffee break, is Chris Lintott, who'll be talking to us about the EPO and Zooniverse.
Thank you very much. I shall try and make my advert brief. Hopefully you can see my screen.
Yeah, we can see.
Great. Fab. I want to quickly talk about the work we've been leading here in Oxford with collaborators in Belfast, Edinburgh and elsewhere to make it easy for those who are using Rubin Observatory data to make use of citizen science projects. You want to do this for 2 reasons. One, because it helps with science. For example, on the left here is a result from the well-known Galaxy Zoo project from Brooke Simmons, which shows the bar fraction of galaxies over time. But while doing your science, one can also carry out public engagement. These are projects that involve large numbers of volunteers, usually online, sorting through data, but on the right is a picture of us projecting galaxies to be classified onto the wall during Oxford's rather damp Winter Lights Festival a year or 2 ago, where we had crowds of people classifying galaxies by running from one side of the street to the other. These projects are also useful for discovery, for finding unusual things in the data, and I'll say more about that in a second. I should show you a proof of principle that this works. So let's use a recent example from the Planet Hunters project run by Nora Eisner, who's now at Flatiron and at Princeton. This sorts through data for tests to look for transiting planets. And in the first couple of years of the test mission, we've been responsible for finding the majority of long period planets in tests have been found not by algorithm, but by volunteers online inspecting the data by eye. And the yellow and red dots here are Planet Hunters discoveries in this period radius plot. We spent a long time building infrastructure for these types of projects so that there's no need for anyone to employ their own web developers. We have a platform called the Zooniverse, which hosts more than 2 million registered volunteers, more than 200 projects, not just in astrophysics. And those volunteers have contributed about 500 million classifications over the last decade or so. Most relevantly, the Zooniverse has a project builder. If you go to zooniverse.org/lab, you'll find a web interface that lets you, in the case of a typical astronomy project, probably takes about an hour to build a version of your project that you can share with people. And we've spent a lot of time, and our in-kind effort is to support the development effort to integrate this system with the observatory data system, so that you'll be able to transfer data from the observatory across to Zooniverse and back seamlessly, so that building this sort of project becomes part of the normal way of doing science with Rubin. I should say we've added some capabilities specifically for the observatory. In particular, we've done a much better job of enabling translations. So for a European project, I think this is important. We know that projects do well where they're available in languages that aren't English. So it's very easy to crowdsource the translations. And we're also creating an organization, which in Zooniverse terms is a collection of projects. So the project will promote those projects which belong to the Rubin organization, so that we can have a collective community of people who are contributing perhaps to many different kinds of observatory science. The last thing I want to talk about is the fact that it's impossible to talk about these projects now without mentioning machine learning. Obviously, the kind of computer vision problems that typically this sort of citizen science projects have addressed have been things that deep learning in particular has got very good at. But we've shown that there are creative and interesting ways to combine machine and human classification. So for example, in the now long-lived Galaxy Zoo project, there is an enhanced workflow where volunteers see those galaxies which our trained neural network think will most likely improve the performance of the network. So not just the ones where there's most uncertainty, but those where it's most useful to get more expert human labels to train a machine. And this sort of active learning loop is now implemented and available for people with projects and a bit more technical expertise. This is work led by Mike Walmsley, who's now at Manchester, having finished his PhD with me here in Oxford. And we've discovered that his trained network can be used to do all sorts of different things as well. So once you've built up a trained machine learning solution using input from a citizen science project, then one could do interesting things. For example, we've built a similarity search currently using galaxies from the Decals survey, but easily generalizable, where you could take a network that wasn't trained for this particular task. So for example, on the right here, this is the network finding ring galaxies, despite the fact it was never trained to find ring galaxies. So in this case, you give it one galaxy and it will find similar features. So one can imagine in the context of a large survey, how one might want to filter, find unusual things, and then search for more of them. So I think this sort of pattern will be really common for users, particularly in the first couple of years of the observatory survey. We're also building on work by Michelle Lochner in South Africa, who built a system called Astronomaly. This is a recommender system. So in the same way that Amazon tells you to buy books by your favorite authors, and by extension, will find books that people who like things that you like also like. Astronomaly, now re-implemented with Zooniverse, will tell you which galaxies you should pay attention to, given a small amount of input on what you're already interested in. So this is a very different way of filtering. But again, I think in the early days of the survey, particularly perhaps for some of the transients and some of the light curve projects that we've been hearing about in the last few minutes, I think this sort of way of working may be very powerful, and it's available on our platform. Finally, we've got the idea that finding unusual things is a relatively tractable machine learning problem, but finding interesting things is much harder. So we're beginning to try projects that, instead of asking volunteers to classify galaxies, to tell us, for example, which is a spiral and which is elliptical, we're asking volunteers simply to tell us which unusual things are interesting. So we're ruling out things that aren't interesting, like satellite trails, thank you, Elon, compact sources and bright stars, and hoping to get through and find the particularly unusual and interesting things in the data set. These modes of working are all being developed. What we need right now is input from anyone who has a large data set or a science case and would like to talk to us about maybe doing citizen science with some precursor data, or in the early days of the survey. I'll be on Slack and I'm available on Twitter and by email if people have ideas. Thank you very much.
Thank you very much, Chris. It's hugely exciting to see all this work. And as someone who loves working with citizens, I hope you'll see real value in them contributing to your science. And it's great that Zooniverse are building all these citizen science tools and interfaces for Rubin. Are there any questions in the room or on Slack? Okay. So Chris, the main way you want people to interact with you is to come forward with potential projects at this point?
That's right. We're at the point where we're trying to test what we've built against the things that people actually want to do. So if people are thinking about large data sets that will need sorting through, either in the run up to the survey or in the first few years of the survey, it would be great to hear from them in the next few months.
And can you tell us, you mentioned precursor surveys. So in this system where you've built to kind of retrieve the data from Rubin directly, is there potential for HSC to be included?
Yes, we're working on that for sure. But we've also worked with, I didn't really get time to talk about the stuff we've done with the brokers as well. So we've also worked with LASAIR and others. So I think if people come in with ideas about what precursor data they need, we can add that to the system and use it as a test.
Okay, thanks. And one last question from Fed.
Hi, this is obviously amazing and outstanding, and thank you for giving this talk and telling us about it. Do you have a sense of how large the community that responds to a specific project has to be to get a reliable result off of it?
Yeah, it's very difficult to say in general, but we find that there are an increasing number of projects that attract thousands, not tens of thousands, but thousands of volunteers who are then pretty committed. And it's not hard for us to find those. We've got more volunteers who want to do astrophysical projects than we have astrophysical projects. So I think a rule of thumb would be that if you think about having 250,000 interactions with your data within a month or two, that's a medium-sized project for us. And so you could start to work out how many people that means looking at each thing and so on. Some projects get it's not uncommon for projects to get millions of classifications, but we have a crowd waiting. And so this isn't a recruitment exercise. It's about putting the right problems in front of our volunteers who are keen to help.
Thanks very much, Chris. So I hope you'll agree you've seen a showcase of some really diverse and exciting projects that are coming into the in-kind program through all of your efforts. So onward and forward, and we hope to interact with you more. And with that, I don't know if there are no announcements.